Greetings again everyone, welcome back to my channel. Here we have a pair of simultaneous equations that we are going to solve. Where in equation 1 we have x plus y is equal to 6, and equation 2 we have x times y is equal to 36. Now by looking at both equations we can see that our solutions will be complex, so join me as I go through our solutions. You may pause this video and check out my playlist on how to solve simultaneous equations like these, and then try and attempt this question. So I'm just going to go ahead and write my solutions below here. Now the method that we're going to be using to solve this problem is what is known as the substitution method, where we can substitute the value of y, which in this case in equation 1 x plus y is equal to 6, we make y the subject and have y is equal to 6 minus x. Then we have equation 2 and we sub the value of y into equation 2, where we have x is going to now times 6 minus x, and we close the bracket and we have that equal to 36. And now we expand our brackets using FOIL and we have that equals to 36. We're going to take this 36 that we have right here and it's going to come over to the left hand side of the equation. It's a positive, it comes over as a negative. Now we take negative x squared and we're going to switch it around with 6x just to have our negative x squared at the front of our equation. So we therefore have negative x squared plus 6x, and as we say, we take the 36, bring it over, it's going to be negative 36. We have that equal to 0. Now in our quadratic formula, a cannot be a negative, so we divide our equation by negative 1. So dividing that by negative 1 will get rid of the negative a value, so we would have x squared minus, so we would have minus 6x, and we know that negative into a negative is a positive, so we have positive 36 is equal to 0. And then we find the value of x, where we use our quadratic formula, where we say that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where in this case we have a is equal to positive 1, so our a value is 1 and our b value is going to be negative 6, and the value of c, which is our number term, is 36. So all that we have to do is just to plug in the values of a, b and c into our equation. So let's go ahead and do that. So here we're going to have x is equal to, we have negative times a negative, it's going to give us a positive, so we have positive 6 plus or minus the square root of negative 6 squared, that's going to be 36, minus 4 times 1 times 36, that's going to give us 144, so we have 36 minus 144 all over 2. So then our value of x can be further simplified as 6 plus or minus the square root of negative 108 all over 2. So then we further simplify the value of x as follows. So we would have 6 plus or minus the square root of factors of 108. We have 36 and 3. So we could have the square root of 36 times 3 times our negative value here is going to be the square root of negative 1. So we just factor out negative 1 as well. And the square root of negative 1 is a complex value, which is represented by the letter I. And we have this equation all over 2. So now we have x is equal to 6 plus or minus, not the square root of 36 is 6. So we'll say 6 times I times the square root of 3. Now we can simplify our value of x a bit further. Since it's all over 2, we could have 6 over 2 plus or minus 6i times square root 3 over 2, just the same. And then we say 26 plus 3 times, we do the same here. So therefore, for our first solution of x, we have x is equal to 3 plus 3 times I times the square root of 3. And for our second solution of x, we have x is equal to 3 minus 3 times I times the root of 3. So these are our solutions of x, and now it's time to find our solutions for y. So if we have two solutions for x, we'll also have two solutions for y. We have y is equal to 6 minus x. So we would have y, and in this case we would have the first solution of y being 6 minus x. And in this case we refer to the first value of x, and then we just do the same for the second value of y, which is that y is equal to 6 minus the second value of x. So we're just going to find the solutions of y. Starting with the first solution of y, we would have y is equal to 6 minus the first solution of x, which is that x is equal to 3 plus 3 times I times the square root of 3. So we go again and say that y is equal to 6, and we have negative 3 as negative 1 times 3 is going to be negative 3, and we have minus 3 again times I times the square root of 3. So we say 6 minus 3 gives us 3, and we have minus 3 times I times the square root of 3. So this is the first solution of y. Alright, so we're just going to look at the second solution now. So as we said before, that our solutions will be complex. So we are seeing here that indeed we have pairs of complex solutions. So we have the second solution for y being that 6 minus the second solution of x, which is 3 minus 3 times I times the square root of 3. So then that means that y is equal to 6 minus negative 3, as negative 1 times 3 is going to be negative 3, and negative times a negative will give us a positive. So we have positive 3 times I times the square root of 3. So then our second solution for y is that y is equal to 3 plus 3 times I times the square root of 3. So this is the second solution of y. So now we have a pair of solutions for x and a pair of solutions for y. So let's actually go and record this. So we have our pairs of solution for x and y, as we have x1 comma y1 to be 3 plus 3 times I times the square root of 3. We can put these in brackets just to avoid confusion, as we are going to write the solution of y1. So the first solution of y is 3 minus 3 times I times the square root of 3. And we also have for second solution for x and y, so we have x2 comma y2 as 3 minus 3i times the square root of 3, and we put that in bracket just the same. And for y2 we will have 3 plus 3 times I times the square root of 3. Alright, so these are our solutions. So we're just going to have this and just separate it from our working out, as we'll be verifying our solutions shortly. So these are our solutions, and we would just want to have this safely up top here. So let's go ahead and verify our solutions. So let us check if these solutions are true solutions. So let's verify. So in verifying our solution, we take our equation 1. We have x plus y is equal to 6. Now we can choose either of the solution pairs. For this video, we'll be going with our first solutions for x and y. So we see that x plus y is equal to 6. So let us see if we can verify that. So x1 is 3 plus 3 times I times the square root of 3. So we'll just have that here. And then we say plus the value of first solution of y, which is 3 minus 3 times I times the square root of 3. And we have that equal to 6. So let's just not forget our equal 6. Now we can actually group our terms. So we would have 3 plus 3 right? So we'd have 3 plus 3, and then we'd have plus 3 times I times the square root of 3 minus 3 times I times the square root of 3 is equal to 6. So as we can see here, these are going to be cancelled out, and what we have left is 3 plus 3, and 3 plus 3 is equal to 6. So we have 6 is equal to 6. So here we have it. This first solution is now verified. So we'll just move on to our second pair of solution. And also we'll be using equation 2 to verify our solution. So equation 2 says that x times y is equal to 36. Now in this case, we'll be using the second solution sets. So we have x2, y2 is equal to 36. So let's go ahead and write that down. So our second solution of x is that x is equal to 3 minus 3i times the square root of 3. So we'll have that. We put that in brackets as we will be having y beside it, which is that y is equal to 3 plus 3 times I times the square root of 3. This is the second solution of y. Now if you look closely, you will see something interesting. We have an expression here. This expression is referred to as the difference of two squares, where we have a plus b. So a plus b is this one, and we would have times a minus b, which is this one over here. So whenever we see something like this, it's the same as saying a squared minus b squared. So this is what you call the difference of two squares. Now seeing here that our solution sets represents the difference of two squares, we're just going to write our equation having this in mind. So we'd have 3 squared minus 3 squared times I squared times the square root of 3 squared. So we're just going to square all of these that are here. So 3 squared is going to give us 9 minus 3 squared here again is going to give us 9. And then we have I squared. Now let's look at I squared. I, as we said before, is the square root of -1. And if we square it, it means that we'd have the square root of -1 times the square root of -1, which is going to equal to -1. We could also look at it from the angle of having it being squared. So the square root sign is going to be cancelled out by the square sign, which is going to leave us with just the -1. Since we are multiplying this value, we would have it in brackets. So we'd have 9 times -1. And then again, just using the same principle here, we would have that times 3. So we have 9 minus 9 times -1 times 3. Now here we have -9 times -1, which is going to give us +9. That times 3 is going to give us +27. And we said before that that's equal to 36. X times y must give us 36. So let's put that here. And in verifying our solution sets, we must check if that is true. So we have 9 plus 27, and that is equal to 36. So there we have it. Our solution sets are checked and they are verified and correct. Thanks again for staying with me to the end of this video. It was a lovely lesson. If you like this video, please smash that like button. Also, please share this video and subscribe to my channel for more updates like these. And until then, take care.